throughout the year, we're going to be talking about different sets of numbers, and so we want to come up with a new way to represent intervals of numbers. And that's our goal for today. And to start off with a couple vocab words, we have a bounded interval and an unbounded interval. So our first one, a bounded interval is a subset. Okay, subset, that means a smaller portion of real numbers. Remember what real numbers are? They can be found on a number line that has a beginning and an end, or endpoints. So think about something like all the numbers in between 3 and 7. It's a smaller set, it's not every number, but it definitely has a beginning, 3, and an end, 7, and includes everything in between. We could also have an unbounded interval. That's a subset of real numbers that continues forever in one or both directions. So we could say every number larger than 5. It has a starting point at 5, but then it's going to continue to increase forever, so we call that unbounded. So let's go back to some things we have learned in the past. Let's think about this inequality. Now if we read this, it says -4 is less than x is less than or equal to 3. But in this case, I'm not talking about one particular number, maybe -0 or 2 or -3. Those would all work. And I'm not talking about just one number. I'm talking about every number in between these two. So if we want to show that on a number line, because of the line underneath the less than symbol, we know that 3 is included, so you put a closed circle here. There's no line, so the -4 is not included, so we put an open circle here and shade everything in between. There's a few different ways you could say it in words, but let's go the long way for now. This means all real numbers greater than 4 and less than or equal to 3. Now here's the new stuff, interval notation. What that does is it actually shows you written out what the first number and the last number shaded are. Now technically -4 is not the first number shaded since it is not included. But we know that -4.000000000000001 would be, and we don't want to have to write all that. So because the circle's on -4, we write that number first, comma, the last number shaded is 3, so we write a 3 here. Now, in our inequalities, we know we have two different symbols, if the number is included or not. With our circles, we have two different symbols, if it's included or not. And even here with our words, that or equal to gives us a clue. So we need something in interval notation to show you the difference between if the number is included or if it's not. So here's what we do. If the number is not included, we put a parenthesis around it. And if it is included, we put a bracket. So let's write that off to a side. If it is included, you put a bracket. And if it is not included, you surround it by a parenthesis. Okay, let's try another one. What about x is greater than or equal to 2? On the number line first, it's equal to, so the 2 is included, gets a closed circle. We're shading all the numbers greater than 2, so that would be the numbers to the right. And again, in words, please don't write x is greater than or equal to 2, because this x really stands for every number. So we would write all real numbers greater than or equal to 2. What about the interval notation? Well, what is the very first number that is shaded? In this case, it's a 2. What is the very last number that's shaded? Well, this shading doesn't stop. It keeps going forever. So we write a parenthesis. So the shading starts at 2 and it ends at infinity, or it never ends. Now we have to decide about the parentheses and the brackets. So let's see, the 2 is included, it's equal to, so the 2 gets a bracket. Alright, let's see, this is something near infinity. Well, the shading keeps going forever and ever and ever. The bracket would signify that that's a number that is included. Well, infinity isn't really a number, it's more of an idea. So the rule is anytime you have infinity, you always put a parenthesis there. So infinity will always get parentheses. Last one. X is less than 3. Okay, so here we go. We have our number line. It is not included, so we do an open circle. X is less than, so we're going to shade to the left. For our words, all real numbers less than 3. Okay, for our interval notation, there's the 3 here, but this is actually the ending point of the shading, not the starting point. This is the furthest to the right it goes. So the 3 will be the second number. Where does the shading start? Well, since it keeps decreasing forever and ever and ever, it starts at negative infinity. Infinity always gets a parenthesis. The 3 is not included, so that also gets a parenthesis. Why don't you push pause and work on the rest of this worksheet, see if you can get all of these filled in. I haven't filled in the words here, but here's the inequalities, the number lines, and the interval notation.